Everyday AI is passive by design. It requires your input to wake up, does exactly what you ask, and immediately goes completely dark again. This creates a heavy micromanagement problem. If you need help with a complex task that has 10 distinct steps, you have to sit there and manually guide the AI through every single one, feeding it new instructions along the way. Researchers are looking to solve this by shifting the core function of the technology.
But an engine just spinning in circles isn't very useful. We have to look at what the AI is actually doing while it spins inside that loop. This brings us to the second box in the diagram, the cognitive cycle. This internal logic is broken down into a specific sequence: perceive, reason, act, and observe. First, the agent takes in information about its environment, the perceive step. Then, it uses the language model's logic capabilities to reason through the problem and decide on the most effective move. Next, it acts on that plan. And crucially, it strictly observes the results of that action to see what actually happened in reality. It is a rigorous, four-step operating system. It forces the AI to analyze its surroundings before making a move, preventing it from blindly guessing its way through a task. Of course, in any complex task, things go wrong. The agent will eventually make a mistake or hit an unexpected wall. Look right below those 4 cognitive steps on the diagram. There is a simple but vital instruction: repeat until done. As this flowchart shows, when an agent observes that its action failed, it doesn't just crash. It loops that failure data right back into the perception stage, reasons out why the previous attempt failed, and tries an alternate path. A standard chatbot stops at an error and waits for you to type in a fix. The agent assesses its own error and course corrects. This ability to self-correct and iterate, rather than achieving perfection on the first try, provides the foundation for digital autonomy. We have a looping engine, and we have a reasoning operating system. But how does an isolated digital brain actually execute changes to external files and software? The final bridge is tool execution. As the third box states, model proposes, code executes. The language model itself doesn't directly manipulate your computer. It simply outputs a text-based proposal, which then triggers external code to run the actual task. In this architecture, a tool is just a structured request sent to an external application. The agent might send a request to a web browser to scrape data, ask a calculator to verify a mathematical output, or call a software API to populate a spreadsheet. These tools act as the literal hands of the AI. They translate abstract, digital reasoning into concrete actions in the real world. Pulling back to the full picture, we have a continuous looping architecture, a resilient reasoning cycle, and a suite of code-executing tools. Combining these 3 elements moves the AI past the limitations of a passive chatbot and into the role of a functional digital employee. The technical frontier has moved beyond training smarter standalone models to the coordination of thousands of these autonomous agents.